So yesterday we talked about SOHCAHTOA and Pythagorean theorem. What must we have to use SOHCAHTOA and Pythagorean theorem?
Right angle triangle.
Right angle triangle. Perfect. Now, I mean, not all cases are perfect. We don't always have a right angle triangle. We have other types of triangle, and we have to use. We can't use SOHCAHTOA and Pythagorean theorem to solve. So today's lesson, we're going to do the sine law. So the sine law is used with oblique triangle. So what is oblique? Sorry? Where angles, there's no right angle triangle. There's no 90 degree. So an oblique triangle is any triangle that does not have a 90 degree angle. So it does not have it. Okay? And remember that in an oblique triangle or in any other triangle, when we have the letters, remember we talked about this yesterday, capitals on the outside, right, for the angles, and then angles are across from their corresponding sides. So what do we call the sides? So this side is A, and then we call it with a small letter A. This side is B, and this side is C. When we're talking about oblique triangles, we don't have what we call hypotenuse and opposite and adjacent. There's no such thing as that. Okay? We only go with the letters that corresponds to the angle. Okay? Now, the question is, when can we use the sine law? The sine law can be used when you know two angles and any side. When you know two angles, can you tell what the third angle is? You know two angles. What would the third angle be? What do you do? I'm talking about angles.
So we use the
Angles,
sine.
Okay. You know two angles,
Yeah.
and you want to find the third one. What do you do? 180 take away the other two, right?
Yeah.
Remember that if you know two angles, right? You want to find the third one, you just do 180 minus the other two. Okay? So when you have two angles and one side, to find the third angle, you do the 180 minus the other two. And then to find one of the other sides, this is, so I'm looking for a side. The formula is the following. A over sine A equals B over sine B equals C over sine C. And this is used to find an opposite side. We're going to look at examples. It will make more sense when we look at examples. Now, you only can use two ratios at the time, which means, let's say if you know A and you're looking for B, you're going to use the A and the B together. Okay? If you know C and you're looking for B, then you're going to use the B and the C. You're going to forget about the A. You can't use all three at the same time. You have to only use two. The one that's given to you and the one that you're looking for. Is that clear? Okay. Now, so you either know two angles and or if you know two sides and one corresponding opposite angle. This is very important here. You must have a corresponding opposite angle to one of the sides. So let's look at this. if I know two sides, so let's say I know this is 10 and this is 5, okay? Then I must have either angle A, because that's a corresponding opposite side to the 10, or I must know what B is. I must have an opposite angle to the side. Otherwise, I cannot use the sine law. Okay? Now in this case, if I know what angle A is, and I know what side A is, what angle do you think I'm going to be looking for? I'm looking for angle B. Why? Because I know side B. Okay? And remember that the ratio is B and B, A and A. Okay? So that means I'm going to have to use this. Okay? We'll talk more about this. We'll see examples. Now when you're looking for an angle, you use this formula. So it's the same formula, except it's flipped. Okay, we put the sine on the top. And remember, this is called the sine law. That's the reason why it's called the sine law, because it's sine A over A. Okay? Again, this is when you're finding an opposite angle. Right? So let's say in this case we're finding angle B. And then again, you only can use two of the ratio. So in this case, we're going to use A and B. Okay? So I have a triangle here. Is this triangle a right angle triangle? No, it's an oblique triangle, right? Now since it's an oblique triangle, I can't use SOHCAHTOA nor Pythagorean theorem. I have to use sine law in this case. Now what do I have? What scenario do I have here? Two angles and one side, right? So it's the first thing. Two angles and one side, and I'm looking for which side? Side D. So I'll need to find this right here because that's what the question is asking. Okay? I have an angle its opposite side, right? And I have an angle and I'm looking for its opposite side. All right? So let's set it up. In this case, I have letters E and D, right? So since I'm looking for a side, then I'm going to go what? What do I write first?
E over sine D over
Sine.
E over sine E equals D over sine D. The letters can change to whatever letters you are given. They don't have to stick with A, B, and C. Okay? So you see that I have E over sine angle E equals D over sine angle D. So now I have to plug in the information, plug in the values that are given to me. What side E equal to? So 38 over sine 95 equals, do I know D? Over sine 40. Okay? So you see that I've already set it up. I only have one unknown. There's only one thing that I don't know. Okay? So how do I isolate for D? What do I have to do?
Multiple.
Cross multiply.
Cross multiply.
So when I cross multiply, what would it look like?
40 multiplied by 40, sin 40 multiplied by 38 divided by sin 95.
So now all what you have to do, you have to use a calculator to find side Z. Sides to how many decimal place? 1. So what do you guys get? So 38 times. Make sure that your calculator is in degrees. .5. Please make sure that you got that, because that tells me that you're using a calculator. Remember, we have to round it to 1 decimal place. Sides to 1 decimal place. We got that? Do we have a calculator? Hold on. Close on here. Okay. Now, let's look at the second example. So what do I have in the second example? 2 sides and 1 angle. So what scenario do I have here? First or second?
Sine B over B. Sine C over C.
Yep. So I'm looking for an angle. The important part is you need to understand that you have an angle and its opposite side, right? You have a side and you're looking for its opposite angle. Okay? So let's set it up. I'm going to use A and C, right? So sine A over A equal to sine C over C. Angle A is 59 and side A is 19, so I have to fill out the values right now. And again, same thing, cross multiply, right? That's why we use the different versions, is because it makes it easier for us to solve. Okay? If we pick the wrong version, it's not wrong, it's gonna make it a little bit harder for you to solve. Okay? So I can cross multiply. So I would get 12 sine 59 over 19 equals to sine C. So what answer do you get when you do that?
0.5
over 1,
Okay, 0.5. 3 or 4?
1 4. If you're rounding that up to 4.
Okay, so we have to. All right. I'm not done yet. This is not an angle. Remember yesterday we said anytime we're looking for an angle, what do we have to do?
Second shift.
The second shift. Remember that sign with a -1 on top of it? We have to do that. Okay? So, basically to find angle C, I have to do the inverse. So what do I get?
33.
33.
And remember, angles to the nearest degree. doesn't make sense what we're looking for. Okay, so the scenarios are you have two angles on one side, or you have an angle on its opposite side and then another side and you're looking for the angle.